We have a system running in our team which can detect the attack contract even before the hackers send the attack transactions, because they need to deploy an attack contract and then send the transaction to attack the protocol. So even before the attack transactions, when the hackers deploy an attack smart contract, our AI-based engine can precisely identify the malicious contract.
Scraping Bits is brought to you by the following sponsors. MEV Protocol. Maximize your ETH staking value with MEV ETH, exclusively on mev.io. And Composable. Execute any intent on any chain, coming soon to mantis.app. That's mantis.app. GM everyone, my name's DeGatchi, the host of Scraping Bits, and today I'm with Andy Zhou. Pleasure to have you on.
Thank you, DeGatchi. I'm also very honored to be here.
Oh, honored. Thank you so much. Just for the people that aren't familiar with you, who are you and what do you do?
My name is Andy. I'm the CEO of Blocksec, and I'm also a professor in Zhejiang University, China, a very famous university in China. I also have more than 10 years of experience in the cybersecurity area. Previous, I'm working in the smartphone security. Then I switched to smart contract security, for a couple of years.
What was your early days in smart contract security? Were you doing manual auditing or did you skip straight to automation, kind of like what I did?
Yeah. For the smart contract security, basically in my company or in our research team, we do both the static ones and the dynamic one. So for the static one, we have developed a couple of different techniques, to enhance the static analysis of the smart contract. That's because most of the tools currently available in the community have some common issues because they have too many false positives. Like if you have ever used some tools which are available in the community, they have many false positives. Like if you detect the reentrancy issues, then you throw a simple smart contract into the tool. I think it may report many reentrancy issues or many other issues. But when you manually check this report, you will find most of them are false positives. So we find that the false positives are the main issues of the current static analysis tools. And the fundamental reason of such false positives are that they do not understand the semantics of the smart contract. So the semantics means that if you say 20 token, right? So you have the variables for the balance of each owner, and you have the approved value, who approve what type of amount to Lawrence, you need to Lawrence value. So basically, in such smart contract, you need to precisely identify which variable means the balance, which variable is for the Lawrence, something like that. And if you have this, then you have much better precision for the static analysis tools. So this is, I think, one insight we have obtained from our experience when developing the static analysis tool. And for another insight when we develop our static analysis tool is that you need to have a very good taint analysis engine to tell which one is correlated to another variable. That's because exactly. Because the data flow analysis is a basic technique used by the static analysis tool. And you need to model the memories, you need to model the storages, you need to find the taint, you need to program the taint propagation rules to perform a very precise and also high efficient taint analysis technique inside your tool. So these two key techniques are very effective in our static analysis tool. So in our research team, we have this static analysis tool running, and we analyze each new created smart contract on the blockchain. And we will, report the 0-day vulnerabilities we have identified to the developers. Unfortunately, some of the developers, they do not care about the vulnerability. And we even do not, find the place to report to them. So that's very sad. But the static analysis tool, if you want to a very effective static analysis tool, you need to have the semantics, you need to have a taint analysis engine. So this is our experience for the static analysis tool. And besides the static analysis tool, we also have a dynamic analysis tool running in our research team. That's because we want to identify the malicious transactions, right? So not only the vulnerable smart contract, we also want to detect the malicious transactions. The malicious transaction means that whether this transaction is attacking some protocols, attacking some smart contracts. So how do we do that? So we have a customized virtual machine with the capabilities of intrusion. So we can write our own detection rule that can be easily hooked into the virtual machine or the execution engine of the smart contract. And we will capture different signals to show which one, or whether this transaction is malicious or not. I can give you some high-level idea of this, or whether the sender of these transactions have some labels like this sender has performed some attacks previously, where the funds come from, right? Something like that. So we combine different signals together to put a risk on the transaction. So this is how our detection engine works. And we also running this detection engine in our research team, and we can capture the attack transactions in the first place. So this is what we are currently doing for this static and dynamic analysis.
Yeah, that's interesting. I've done the same thing with my static analyzer. Is the taint analysis is basically essential, but then you use whatever you do with the static analyzer, you transfer all that data into a fuzzer, right? And I was building my fuzzer as well, and it's really interesting to see how people approach it. But there are very interesting solutions. People think very sequentially within this space, and there's a lot of dimensions to think of, which I think sequentially is not the right answer. Let's talk about the dimensions. You have the call data, right? But then you also have functions and the contracts, and then you also have the other dimension, which is the state. So it's very context dependent. And so now you have all these 4 different variables, dimensions, and they all impact each other with just the slightest tweak. So for example, you can have contract A, contract B, all of their functions. Now you have to order them in all these different ways, but there's not just the single one of function A and function B and function A. You also have the ability to do function A, function B, function B, function B, function A. It's a really tough problem. And I think what you've been doing with your stuff is quite interesting. I know you've advanced Falcon recently to now transaction detection. So it's more of like a generalized front runner, but for hacks. And in doing that, it's very thought-provoking. And the front-running game is dominated by these dedicated MEV teams, right? And they do front-running, sandwiching, back-running, etc. And they have dedicated infrastructure, high-frequency trading stuff, where the latency is very small, and they're partnering with each other, block builders, relays, all this stuff. So the question is, how are you able to front-run these transactions instead of these MEV teams?
Yeah, that's a very good question. So basically, because the main target of our system, our technique is not to front run the MEV bots. So we are targeting the hackers, right? So we are targeting the hackers.
Yeah. But so when the hacker submits a transaction to a public mempool, if it's private, nobody can get that. But if it's to a public mempool, then all the other generalized front runners are going to see that as well. So you've got to beat them. So how are you beating them?
Yeah, so it's a very, very good question. So basically, some hackers, because the security is, we always say that security is arm race between the good guys and the bad guys. And in the early days, because it's easy, because the bad guys they do not know the existence of our team and the MEV bots. So in that time, so that depends on how you pay the gas fee or how you pay the bribe to the validator or builders. So that's much easier in early times. But in nowadays, the hackers, they use some MEV bot technique to protect them from being front run. So even today, we're seeing a very interesting technique deployed by the hackers to prevent their transactions being front run by the MEV bot. So basically, in their transactions, they will first check some values, like they will fetch a certain value from another smart contract to check whether the certain value like equals A, and the initial value of this variable is not by default. So when performing the attack, the hackers, they will first send a transaction to set up the variable in another smart contract to a variable like to A. Second transaction is to actually perform the hacks. If you are an MEV bot, because most of the common technique used by the MEV bot is to simulate one single transaction. So if you only simulate the second transaction, you will fail because the condition does not satisfy. The condition is set up by the first transactions. So because of this tricky part, most MEV bot cannot handle this. And we can handle that because we have a technique to analyze the correlation of different transactions inside the memory pool. And we will simulate a couple bundles at once too.
Yeah, you would have to do multiple.
Yeah.
You can't just do one, because if you're just doing generalized front running, the standard is to just replace the addresses. So if it's like multiple addresses, you have to replace them all. And You have to try every option, basically.
Yeah, exactly.
If they are doing the multi-contract stuff with the setup, well, then they would do the contract deployment, and then they'll call a function in that setup contract, set it to the new thing, then they'll use that in the exploit contract. But the way that you would fix that is basically like simulating again, but you would have to actually just check the state of what's being called. And so if that doesn't match the deployment state of that original contract, well, then you have to set that somehow and find that function with like a CFG and finding whatever that was. And then modifying the exploit contract to set that as well, or even just remove it completely. So that is quite difficult. But it's crazy that you've actually done this and now it's working.
Yeah, it's working, but you need to manage development efforts to do that. And you also have a very good and quick, efficient analysis engine for that.
Yeah, it's very impressive. You guys have prevented 20 hacks and around $15 million in losses already. And that was within, I think it was like 6 months, right? Before you launched?
Oh, yeah. So for this prevention of hacks, it's done like in the 1.5 years, in the past 1.5 years. So it's not in 1 month or 2 months. It's a continuous efforts 1.5 year. Yeah.
But still, there's no one else doing this. It's a really great thing. And I think everyone should at least have it because it's an important thing. And even though it might not be 100% savior rate of everyone, because, you know, they have to sign up and maybe there is some very obfuscation techniques that would be different to kind of assess. It's still better than nothing, right? Like you save stuff, it's actually evidence that you've saved stuff. Getting hacked is like the downfall of an entire company and all the users, all the reputation, it's just gone. So it is a very important thing. How did you guys build this? Were you guys using AI at all? Or there's no way it can be completely heuristic?
So basically, we combine different techniques together. And for the detection of the hacks, so we combine the AI-based solution with the behavior analysis ones. So for the AI-based solutions, because we use the AI technique, machine learning technique to detect the attack contract. So we have a system running in our team which can detect the attack contract even before, the hackers send the attack transactions, because they need to deploy an attack contract and then send the transaction to attack the protocol. So even before the attack transactions, when the hackers deployed an attack smart contract, our AI-based engine can precisely identify the malicious contract. I'm not saying that we do not have false positives, but the false positives are pretty much very low. So even in this stage, before the hack transactions, we can detect the attack smart contract. But the problem is that when you identify an attack smart contract, you may not know the actual victim of this hack. That's because sometimes the destination address is not hard-coded in the attack smart contract. They can be passed from the parameters, something like that. So you need to have some fuzzing technique, to trigger that. But if all the targets smart contract address are passed from the parameters, then even the fuzzing cannot help. So for this complicated ones, we cannot identify the attack smart contract at this stage. And for the attack transactions, we use some behavior-based solutions to detect the hack transactions. So the high-level idea is that every hackers, they want to make profit. So you need to precisely calculate a profit of transactions. And if this profit is above a certain threshold, then this raises some flags. So by combining this together, then you can have a very good precision for the detection of the attack transactions. And after detect the attack transactions, then we will automatically synthesize similar attack transaction like the MEV bot does and replace the profit address and put this on a chain. So this is basically how the system works.
With the AI stuff, I can't imagine it being a supervised learning model. I feel like it would have to be a reinforcement learning kind of deal because there's just not a lot of hacks, right? So it's not enough data to really do that.
I think you mentioned a very good point for the machine learning for the malicious smart contract detection, because we do not have much samples to train the model. But in this case, the key insights of how to make these things work is that you need to extract the key features inside the smart contract. Someone just use the sequence of the body code to train the model. That doesn't work because the sequence of the body code is too general. Is too common for this smart contract. You need to extract the distinct features of the smart contract. So what we are currently using, including the control flow graph, the data flow relationship between the key functions, And we also use some the address labels or the property of the creator for the smart contract, together to train the model. It proves to be very effective.
So you basically extract key features. So for example, let's say hard-coded addresses or address passed in as cold data, cold data OXO, for example. And then maybe they do a masking if they're doing a solidity. It's a common thing you see in solidity, masking with 20 bytes of Fs, for example, with the end. That's pretty common in solidity. But if it's a custom high-code contract, I mean, there's got to be a pretty sophisticated hacker, first of all, to do that. But the sophisticated hackers, ones that are really strictly planned, would 100% be using private transactions of custom bytecode and maybe even swarms of transactions to obfuscate. This was something I was studying because I was very interested in this stuff. Proved to be effective, actually. I've never seen anyone do the kind of techniques I found. I might even write an article on it, actually, because I would never use them, but it was interesting.
Yeah. Before doing this research project, I'm also, do not think it works. But after 6 months, I have a PhD student working on that. And after 6 months, we prove it's very effective. And before doing this project, I do not believe that. But after this one, I think it works.
Yeah, it's crazy. I think it's such a remarkable step in the right direction. And there needs to be more tools like this. But this also begs the question, now that you're using AI, how do you kind of see how much AI is going to impact, first of all, your business, and what will be obsolete because of AI, and what can someone do to prepare today for this revolution?
Yeah, so honestly, I'm not an AI expert, so we just using AI applying to our research area to detect the malicious smart contract and to do other things. So I think the potential of the AI in security area has not been fully exploited. And one reason is that for applying AI into the security area, I think you need to have a very deep understanding of the problem you are solving. And because you have a very deep understanding of the problem you are solving, then you can have a very good extract of the features. What I think the future is very important, right? So even for the same smart contract or for the same transactions, if you do not have a very good feature for the training, then the result will be totally different. So yeah, from my perspective, I think the potential of the AI has not been fully exploited because you need to have a combination of a very good AI person and a very domain expert to extract the features. Yeah,
I agree. It's very two different. It's a combination of two fields, two domains. First of all, being good at ML is hard, and then it takes time to learn this stuff as well. Like you got to know math, you got to know everything to do with ML. Like you got to know the packages, libraries, and then you've got to be inside of the crypto space as well with another domain, which is bytecode and also cyber. That also takes time. But I think people that merge from pure AI to crypto, it wouldn't be as hard as going from crypto to AI, I believe, because it is way more difficult in pure AI to get into that. Just because like the math you need and the total understanding, I guess, of our current architecture and how it all works. But it's super interesting. I think what do you think will be obsolete? Because AI is obviously going to change everything. And I think if you're not using AI, you will not have an edge over other people, I think, in all these businesses. Because it's hard to compete. Like I was doing the same thing with the fuzzer and the stack analyzer, but I know people that do AI, and it makes sense because if you're thinking about this infinite possibility space, infinite action space, you can't just brute force that. You need some kind of intuition to filter out all the actions and to know what to actually target. So you need AI for this. But you need something that can iterative. I can't say this. Iterative. Anyway, you need something that can learn over repeated instances, especially if you're running something on all these protocols, all the contracts, millions of instances, right, or runs. It needs to be able to like learn intuition. Otherwise, you're building the intuition into it yourself, and that's very time consuming and also very flawed because you can't think in all those dimensions, and you don't know what you don't know at the end of the day. So it's extremely, I think personally, if you're not into it, you should get into it regardless, because I didn't even know math and I'm getting into it. So if I can do it, anyone can do it. So we'll see. But it's a big dedication.
Exactly. I can share recent experiment on the AI doing by my another student. So basically, because we have a fuzzing system for this smart contract, to find the vulnerabilities. We have an internal system to do that. We use the AI to generate the seed inputs for the fuzzing, and it turns out very effective. So how we do that? So we have 5 smart contracts to be fast. We first input these smart contracts into the ChatGPT. And we will summarize the key functionalities of each function, saying this function, the main functionality of this function is doing what another functionality of another function is doing that. Then after that, I will ask the GTP to say, please generate 50 different inputs for these functions. And it turns out very effective. And we use this as a seed inputs, to further smart contract.
Interesting. Yeah, I think LLMs are actually quite good. The best we have in terms of, I guess understanding with embeddings. I don't know too much more apart from it, but it is like the best effort at the moment. So it makes sense. I think a lot of people are using ChatGPT, but that seems like a really good use case. I know some people like that are doing it to kind of explain the contracts to them. So it kind of removes all the understanding. It quickly helps you get up to speed with it instead of trying to understand the entire code base. Because it could be like a 1,000-line code base, right? Or multi-contracts, multiple thousands of lines. It's really difficult to see the relationship between everything and the dependencies. But I did want to ask, since you have done this new transaction blocking, so now you have the transaction blocking, but why wouldn't you take it a step further and actually try and find all the 0 days and all the contracts? Because if you think about it, if they're a sophisticated hacker and they actually know what they're doing and they're going to target someone, and let's say it's like a $600 million hack, like Ronin or something, or maybe something more realistic, like a 200 million or 20 million on a protocol, they would just send a private transaction and you wouldn't be able to block that. Why wouldn't you go fully invested into the 0 days, preventing all of them? Because then if you find it, you can just private transaction that, and you kind of save everything to begin with.
Yeah, a very good question. I think yes, we have some alpha project inside Blocksec. We are actually doing that. So because for the Falcon block, we can detect the malicious transactions on the chain or in the memory pool, but for the private transaction, we cannot see that. So we want to push the effort a little further, to detect the attack smart contract. So this is the current stage, and we also want to put the efforts a little further, like what you said, to detect the vulnerabilities, to detect the vulnerable smart contract even before the hackers. As I just said, we have the fuzzing systems to do that, but currently we are still improving our fuzzing system to detect the vulnerabilities, 0-day vulnerabilities for the smart contract on the blockchain. I think there are a couple of 2 or 3 challenges when to do the fuzzing for the smart contract to find the vulnerabilities. One of the challenges, because when you fuzz a smart contract, you need to generate the inputs of the smart contract, basically the transactions. But for the smart contract, you need to generate a serial sequence of transactions, to trigger the vulnerabilities. And sometimes the sequence of the transactions, they have dependency on each other. Like you need to have first transaction and a second transaction and a third transaction, and only the sequence of these 3 transactions are transaction 1, 2, 3, then they can trigger the vulnerabilities. So you need to generate the sequence, a couple of transactions, and you need to understand the dependency of these transactions. This is pretty much hard currently. So it's a challenge 1. And for the second challenge is that you need to have a very oracle, to determine whether there is a transaction. Let's say you send a transaction to the smart contract, then how you determine you trigger vulnerabilities? Of course, we can currently use the similar technique of the profit. So we will calculate the profit of a transaction. So if this transactions triggers a very high profit or cause the hash factor of some lending protocol to be too big or too small, then we'll see there is a vulnerability. But you need to have different types of oracles to summarize for the fuzzers. So this is the second challenge. Yes.
That second part, it's quite interesting because if let's say a new protocol came out, right, and it has a token, and it hasn't got any liquidity pools with big tokens. It might be with another token that's not even, you can't even price it, right? So it's a giant hurdle. Have you ever thought of how you would approach that with that kind of oracle?
Yeah, exactly. So this is another challenge because you need to prepare the environment for the feathers, and you need to prepare like the maybe you need to prepare the DEX pools. You need to prepare different tokens. You need to feed the price of these tokens into your system. You need to prepare different kinds of things into the feathers. So it's very complicated. So we can say that for the simple vulnerabilities like the reentrancy ones, it's very easy to trigger for the feathers to trigger. But for some complicated ones, like have the price manipulation ones, we would say we are still working on that to be a product-ready system. So we still need some time. But you're right. We are working towards this direction.
Yeah, it's not a trivial task at all. It requires a lot of, it's a lot of complexity, right? And you need to account for a lot of things that depend on other things. So it's like you ask a question, and now you just get two more questions, and now they relate to each other. And it's just continuously all the way down. But yeah, that Oracle thing is probably one of the hardest things. And it just so happens it's also one of the most important, because Oracle manipulation is probably the biggest attack vector. Everything kind of relies on that. And in whatever way, it could be like an internal exchange rate, it could be an external one versus an internal one, so like some kind of arbitrage, which they haven't accounted for. And there is bugs in everything, because human error is just certain, right? And the amount of interactions that it can occur with a protocol is not going to be accounted for. There's new protocols coming out every day, which your current protocol can now interact with. And it could be a sequence of 5 different protocols in that regard, and it's not easy. But whoever can, I think you need AI, because you need AI, not I think, but because you have to think spatially of all these different functions in different contracts that are vulnerable. You can't think of them sequentially because there's just so many possibilities, right? So I think I was talking to someone before earlier this year about this, and I was talking to him about the pickle finance exploit, and it's a really interesting one because it has 8 vulnerabilities in it, and if you missed one of them, you wouldn't have the exploit, and it had to be in a specific sequence. And this exploit actually consisted of 5 custom contracts. So it was 5 custom contracts to basically build out the context in which these sequences of vulnerable functions could be used in a specific way. And so another part of it was understanding that let's say in Solidity, right, you have an address and bytes 20. They both mean the same thing. And people overlook this because you do need to know what these types mean, and everything is just bytes. But basically what they were doing, which I found was really, really fascinating, was they created this contract, which was like a fake underlying token, and the fake underlying token .balance of returned an address. It didn't return an actual amount. And that's not true, because an actual amount is just bytes 32 and an address is bytes 20. So you can pass in the address as uint256 because it is technically that, right? And so that actually created this entire chain because it created like a delegate call situation where it was being used, and that's how it kind of happened. But it was really interesting. You have to generate contracts that do specific things which enable new sequences, and this is not trivial. This is not trivial at all. To be able to generate contracts to enable an exploit, and 5 of them at least, it's an extremely fascinating problem, and I think it is very stimulating, and I think there's nothing better to do than this kind of stuff. I love it so much. But yeah, this kind of stuff is really hard. And have you thought about all of this stuff? Like, what are your kind of techniques that you're looking into now? Obviously, I just said spatially looking into isolated functions and seeing how they interact with each other. The relationship stuff is definitely one of the hardest parts. So how are you kind of tackling that? Because taint analysis is frankly not enough.
Yeah, so for the relationship between different smart contracts, so we are currently doing a very interesting thing. So we will manually connect the top 10 DeFi protocol, the smart contract of the DeFi protocol. Then we will perform the manual analysis to draw a figure of the relationship between different smart contracts. As the WST ETH can be used as collateral into a protocol ABC, then we will draw a line between these protocols. And if one token, can be used as the underlying token of another smart contract, then we will connect these protocols together. So basically, we manually, of course, using some scripts to want to get a whole picture of the relationship of different top protocols. And we will, using these insights to guard static analysis and fuzzing techniques. So this is one thing we are currently working on that. It's still in early stage, but the relationship we have generated sometimes is helpful for the static analysis and for the fuzzing systems. Another one work we are currently doing is for the type inference. So we want to infer for the input data for the call data inside a smart contract call. We want to infer the type of the input data, like from byte 0 to byte 20. So it's the address, and from another segment of the input is the value or uint32, something like that. So we try to leverage the static analysis to perform the type inference things on that.
Interesting. Yeah, the relationship between stuff, is it kind of like a graph that you're doing? Okay. Yeah, it's difficult because let's say these are a few techniques as well. Like if you have a contract and it has references to other contracts in it, let's say hard-coded addresses, right? It's quite simple. That means you know the kind of space that you can access and how they all connect in that relationship. But there's also contracts that don't even directly reference each other. You can reference them with call data, or you can create a pool that now references a new contract, and that could be a vulnerable, like Vault, for example, something like Hormona, I think it was called Iron Vault or something. It was in the Unit ecosystem.
Yeah, it's not easy, but we can, leverage the on-chain transactions to connect them, because the on-chain transactions can reveal the interactions between different smart contracts, token transfer, something like that.
Okay, but the flaw with that is you're looking at the normal sequences of functions, right? And to find a 0-day, you got to break the norm and you got to do something different. Well, I think it's good to identify what the normal is, and now you know what not to do, how to break it, which is good. Interesting. So what are your plans with the fuzzer? Are you going to pair it up to do some kind of neural network fuzzing? That's Trailer Bits has attempted to say it's not worth it, but quite frankly, it is just not being implemented correctly. And so what's your kind of plan with the fuzzer? Are you going to do neural network fuzzing, assisted, or completely AI? What's the kind of go-to now?
Yeah, and for the fuzzing, so first we try to have a very good type inference system to facilitate the generation of the seed inputs and the mutation of the inputs for the fuzzer. So this is one. And we also leverage the AI to help us to better mutate the inputs or to better generate the seed inputs for us. So we are using AI to do that. And we also, try to speed up the fuzzing process, because we want to have a very efficient one to quickly identify the 0-day vulnerabilities. So this is three different parallel works we are trying to improve the fuzzers.
Okay, interesting. There is something that is a bit different from this tooling conversation. When we think about the space, right, and you're a professor, so you know about this stuff. When more auditors get into the space, right, I think there's access of information is quite out there. A lot of people are explaining how you become a top-tier auditor. People like leading security researchers at Spearbit or Trailer Bits, anything. Even just solo auditors, they're doing really well. With the influx of new auditors, right, how do you aim to really differentiate yourself from these new players coming in? And I guess other firms and other people that are wanted have the skills. Obviously, there's not a lot of them, but they're still coming in. And as they come in, these smarter people come in, maybe even with AI. I know people like Intercepted are doing AI exploit generation. I'm sure you've heard of them. And what are you doing to really differentiate yourself from these people as new auditors come in and new players come into the space?
Yeah, well, that's a very challenging question. I think from my perspective, you need to have a good understanding of the trend of this particular area for the DeFi protocol security area for each year. I think there are different new attack vectors, new types of vulnerabilities, and you need to have a very good motivation or skills, to try to study these new things. And from my perspective, I think how to quickly learn these new things, how to quickly digest the new knowledges, I think is my advantages. And of course, there are many smart people that will come into this field. But I would say that because I have been trained as a PhD student, I know how to quickly into a new area, how to quickly understand the state of the art, how to quickly, find a good problem to work on, and how to borrow the techniques from another area into this area to solve this problem. I think that's my one to differentiate differentiate me from others.
100%. I think if you're thinking about, I guess, a group of people, right, and they're all smart and capable, the main difference is just the creativity. That seems like if you're all on a level field of, which is never true, all just like smart equally, then the biggest thing is creativity, right? We all think differently and have contrarian views. So I think that is a main thing, is like truly believing in yourself and believing when others don't pretty heavily that you can do something and no one else is really doing that, and you believe that it can be done. You might not know how it can be done, but as long as you keep pushing and have the passion to find that, it's really the research that's the main thing. As you said, being able to identify new trends and capitalizing on them is 100% the main thing, and it happens so often. You just got to be prepared with the knowledge to capitalize on it and bounce on the opportunity. Unfortunately, I haven't, because I don't know AI. I've been in the right time at the right place without the right skills, though. I think AI is truly the next frontier, and anyone not upskill into it, I think, is going to be left behind. If in developer worlds, you have like the domain knowledge and also AI, but if you combine them, you're in a world of difference, because you have knowledge of both areas, and so you can think of better problem solutions versus sectioned off knowledge. I guess a good example is understanding math. You look at the world differently to someone that doesn't understand it. And if you combine that with different things like financial sector, then you can think of ways to build really efficient algo trading systems, right? And gain an insane edge over the competition. I think there was this guy actually on AVAX that captured, I think, like 90% of all arbitrages because he just had a math edge. That's what I mean. Like, if you have just like two domains, you can really capture a lot of opportunities, because it's just hard to learn this stuff. And the more domains you can combine, the less competition significantly there is. It just gets culled away. So where do you see yourself and Blocksec in the future? How do you see yourself progressing in your career and in the company itself? And where do you see the industry going and where it should be going?
I think for the industry, because even in the past few years for this new, because the Web3 is a very new area, and we are still in the early stage of this new field. And from my perspective, I think the industry is moving very fast. And at the same time, there are so many security issues have not been addressed by the industry. And we trying to use our lower solutions to help the ecosystem to move fast, but also move secure. Like we have the products for the protocols to protect their assets. So this is one thing. And we also see in the future that there will a couple of different Web3 users into this field. And the users, they also need the security protection, because it's a little complicated for the users to use this product currently. They need to have a very good method, to protect their product keys, to protect their assets, because most of the users do not understand the approve things. So they just approve all the tokens to the malicious smart contract, something like that. So we need to have a very good protection system for the DeFi users, which have not been addressed by the current industry. Of course, there are some companies that are doing that, but we are better ways, to protect the users. So I think this is what we are doing. Yeah.
Yeah, I think on top of the fuzzle, you can expand into like a wallet. When you're talking about protecting users, I mean, there's two different ways or three different ways. It's like the pending transactions, which isn't 100% certain. So you have to go a bit granular, and that could be like finding the 0 days themselves. But if that's not an option, then just even having the ability to embed the analysis in the wallet itself might be good. Even if it's like a quick one, right? They're going to be doing tokens or whatever it is they degen into. But if you can perform some like analysis before they do the transaction, and I think someone's done this before. I forget which company this was.
There are a couple of companies doing that to simulate the transactions and to tell the users the consequence of a transactions if they sign these transactions.
Yeah, I think that's really smart, and I think it's an easy progression into the company or anything that does security. I think is a really great way. It's to directly give it to them. I think it was Vi or something. No, I can't remember. But yeah, those are really good, the simulations, but I think they're kind of flawed because if you're doing like a transaction into an LP, for example, I mean, people do custom bytecode and do conditional functionality. Let's say there was 100K in the LP, then it'll switch to doing something else. So the initial simulation of when it has zero money or whatever it is, it wouldn't come up unless you actually test everything, every single function pathway. That's something I was thinking of, but also there's so many difficult problems. You got to pick your poison. What are you excited for the future of cybersec and AI combining? I'm sure you're going to use it a lot more. What are your kind of plans, and how do you see yourself going down that route?
Yeah, and as for my plan, I think we want to, combine these new techniques together to better protect the community, to better protect the users. And we will continue invest our resources into the AI scenes, AI combined with Web3 security scenes to have a better product. So we want to push things to further, to have a better attack detection system, fuzzing system, better solutions to protect the users' assets. So this is our current plan inside of Blocksec.
Interesting. Okay. Well, I super hope that it gets way better and you're able to do a lot more. You're doing a lot already, being able to prevent all these hacks, but I think there's so much wiggle room for more innovation, and it's only just getting started. I think once people start getting wind of it and you prevent more hacks, it's going to become much more prominent and a lot more competition, which is great. Healthy competition to prevent hacks and actually expand the ecosystem, because the end goal is to kind of replace CeFi, right? You don't want to be waiting 4 months to get rid of money out of our bank accounts. It's pretty ridiculous. So any effort in the infosec sector is actually underappreciated for, I guess, retail and existing protocols. They only really know it until they get hacked, I believe, is actually how a few people got into it. But man, I'm super excited for what you guys are building, and I'm really optimistic about the future with cyber and crypto. But man, I really appreciate you coming on. I'm super glad I got to be the first podcast you jumped on.
Yeah.
I really appreciate your time, Andy. It's been a great chat.
Yeah, honored to be here. Thanks, DeGatchi.